Hey, hi guys, this is a demo on voice agents that draws. We'll also go into the code in this video and we'll also discuss like little bit about OpenAI real-time API. So let me show you the demo first. Let me start the agent here. Hello.
Hello. How can I assist you today?
Can you draw a square on my screen? Okay, great. Can you put it in the center? Can you write like a very small 4-line poem about trees on my screen? Great. Can you make it colorful? Every line should be in one single color. Can you add an emoji in between every single line? I said in between every single line, not at the end of each line. Okay, great. Can you give it a title? Oh, nice. Can you rotate the whole poem upside down? Nice. Can you add more emojis? Okay, it's fine. It added in the end. So since this can draw, right, we can maybe play some game. Can you just erase everything on my screen and let's play tic-tac-toe first? Yeah, can you initialize the tic-tac-toe board for me on the screen so that we can play? Great. Let's put a number on each of the box so that I can tell you where I want to put my turn on. Okay, so do I start? I want to put my X on number 1. It's your turn now.
I'll place my O in position 5. Here's the updated board.
Okay, let me put it on 3. Okay, it's your turn. It's not understanding when its turn is.
Apologies for the confusion. I'll place my O in position 7. Here's the updated board.
Okay, let me put it on 2 then. It's your turn now.
I'll place my O in position 9. Here's the updated board.
What do you mean you want to put it on 9? I already won the game, right?
You're right. My mistake. You've got 3 X's in a row at the top.
Okay,
Congrats.
maybe it's not that smart, but you get the idea. Like you can still tweak the prompts, I guess, make it better. But this is the demo. Let's see how we can build something like this. So let me just open the code here. So there are like these 2 files actually. App.py is the actual start of the file where Streamlit code is present. What we'll be doing is we'll be using this file html display code.txt to actually save the HTML code, the code that you saw getting updated here. This is the code we save it in this file, and this is what is displayed in Streamlit and is rendered as well. I took this file approach because it was getting difficult along with Streamlit to have a WebSocket connection as well with OpenAI real-time API. Since these are like 2 threads running, and then it's because of Streamlit complexities, nothing else. Ideally, you should not use like a file like this in production. But yeah, but what the basic structure of this code is, we'll have one thread running where it will connect to the OpenAI real-time API, and mic and speaker will be the input and output to these to this WebSocket that we'll connect through OpenAI real-time API, and it will update this file. If at all our agent wants to update the code, it will come and update this code. The Streamlit app keeps refreshing, so I've used this auto refresh line here. It will keep refreshing and keep reading this file. So that's how it updates on the UI. So again, keep in mind, this is not the most ideal way to do it, but this is just a workaround to make it work with Streamlit. Ideally, we should be using JavaScript or something for front end to properly render the HTML and all. But yeah, since I don't want to get into JavaScript right now. Let's stick to Streamlit and have this workaround and make it work anyways. So as soon as we click this start agent, it will start this WebSocket instance that we have. And this is the real-time class that it's importing from utils. So in utils, we have everything, basically all the code. And Streamlit it's just that we have this start thread. So this thread is started on this button click. This thread is the real-time OpenAI real-time API thread that keeps running in the background and keeps updating this file. On the Streamlit side, it's very simple. It just reads this file and it updates it here in the HTML text in the sidebar and in the main body of the page as well. It just reads this file and renders this HTML. That's the simple UI code here. Let's go to utils. That's where the main action is. So in utils, there are these three classes: socket, audio input output, and real time. So real time is where all the actual OpenAI real time related code here. So as soon as we hit start here, what happens is when we click this button, we start this real time instance start function here. And what we do here is we send some events. First of all, we connect to OpenAI real-time API. This is where the socket connects, and then we send an event. So this event is of the type session update. We'll discuss about the different event types and messages that we can send to OpenAI real-time API in a while. But just to give you a very brief understanding right now. So in session update, we sort of update the session and give all the information about that session. So here we are saying like this is the instruction. It's kind of like a system message, you can say. And then these are the tools that we are giving it access to. So there is just one tool that we are giving it access to, which is update screen HTML. So this is just a function name, and I've given it a small description. And then there is one property that it has, which is the actual HTML code that it should give us in the argument. So this is the function name and this is the argument of that function. And this is the description for that argument. Like basically I tried to put this description based on what Streamlit can handle, but it can be less complicated. It need not be so complicated because I've asked it to not give SVG and all. I realized like Streamlit was not able to render SVG. So that is one part. So as soon as we connect to OpenAI real-time API, usually we'll send this WebSocket event about session update to set the session. If it's fine even if we don't do this, but it will take all the default values and it's not suggested. So you always start with session update, and this goes only once as soon as we connect. So once we send this session update, we'll also start the audio input output thread. If you saw, like we have this audio IO class. Socket is used for OpenAI real-time API. Let's go through the socket class as well very quickly. It's just very simple. Like it has the connect function and then receive message and then send message. That's all. And then kill is also there, which is used for stopping the agent. But this is just the socket, like just the housekeeping stuff, nothing else. Audio IO is where the mic and speaker interfaces are present. So if you see in this real time, we initialize this audio IO instance, and then we start this audio IO instance with start stream. First, we also get this thread on mic, and then we start this thread about mic callbacks. So send mic audio is another method in audio IO, which starts sending mic inputs in the background to the socket, to the real-time API. But this send mic audio, it's again based on this queue that is there, and this queue gets filled based on this mic callback that we have. So mic callback will put all the will keep putting the data, the mic data on this queue, and the send mic audio will just read from this queue and send it to real-time API. So if you see here, we'll start this thread about sending from mic queue to real-time API, and here we'll start both the audio IO streams as well. Both audio IO streams, as in one is mic and one is speaker. If we go to the start stream method in audio IO, we have one mic stream, we have one speaker stream, and both of them are started when we call this start streams. And then this mic is based on mic callback, speaker is based on speaker callback. So if you want, you can also see these two functions here. Mic callback is just like as we discussed, like putting data on the mic in chunks. And speaker callback is based on this audio buffer. So this audio buffer, we keep adding the output data bytes here, and then it is played. It's returned back as audio chunk, the accumulated one, so that it plays on the speaker. It's just an interface. I had taken this code from some place on the internet. I did it like a while back, and I was not able to find the actual source of it. If I ever find it, I'll update it in the link in the description. But this is not my code. I just want to give credits to someone. If someone finds this, like who this code belongs to, please let me know as well. I'll definitely give the credits. But yeah, this is how this works. And the major place where we'd like to work on is this real-time class, where we'll update the prompts, we'll give the tools accordingly, whatever we want, however we want. And in the real-time class, here we have this handle message method as well. Whatever response we get from the real-time API is handled in this function. So as soon as we get a message, we first take the event type out, and based on this event type, we process it accordingly. So we'll look at this event and how to read this in the real-time docs just in just a while. But so just to give you an idea, like if it's an audio response audio delta event, then we'll send it to this receive audio function in audio IO for it to play it on the speaker. So, and if audio is done, that means basically like it's finished speaking. I mean, we can play the complete audio, but this plays it in real time, so it's like streaming. Rather than here, this audio done event, it's mostly like sending the complete thing when it's done streaming, and then it will also send the complete message, but we don't process that message here. We just logging this. And this is the main part. Like if the event type is function call, when we get a function call rather than a response, this is the place which gets triggered. And here we are seeing if the function call is update screen HTML, if in the message, if this is the event type and this is the name of the function, then we need to update the HTML on the screen. So we'll parse out this HTML code that is there, which we got from the real-time API, and we are writing this to the file. So this is the actual code that is of interest to us, which will actually update the screen HTML that we see. And this is just a simple stop function for stopping all the streams. This is used for when the stop agent button is clicked on the UI. So at a broad level, this is the code. Let's quickly go through the OpenAI real-time API as well. Yeah, so we'll go to the docs. We have like client events here, and also server events. So client events is basically what we can send to the real-time API. So first thing is the session update. So under session, we have only one event that we can send, update. But so this is what we had used to update the session about the tool info that we can give. You can read more about this here, but this is an example that they showed. Like we can set the input output audio format as well, and we can set like audio transcription model here. We can also set a VAD, so if we interrupt the agent, it will stop talking and all here. And tools we saw already. We can also set the temperature, max response output tokens, etc. So this is like a one-time initialization kind of thing that we do in the session update. Input audio buffer, you might have guessed it, like when we are streaming, let's say from a mic, we keep calling this audio buffer. And then I think we call it append. Let me quickly check which one we call. Yes. So here you see we are calling append function with the encoded chunk of this audio from the mic that we have. So this is where append comes in. Like if you see, like, send this event to append audio bytes to the input audio buffer. This buffer is temporary storage. You can write to it later, commit. In server bad mode, the audio buffer is used to detect speech, and server will decide when to commit. So it's like we can keep appending it, and we can send this commit message to tell it like we are done speaking. But what it's saying in the server WAD mode, it's like the server itself will decide when the commit will happen, so that it can generate a response. So I hope this part is clear. Like as soon as the input audio keeps coming in, let's say from a mic, we'll keep calling this append event, and it'll keep appending the chunks of audio. But we'll also have to send an event saying that, hey, this is commit, saying this is all the audio there is. Now generate a response and give back. But in the case of server WAD, we do need not send a commit event. That's why we are not sending it. We only append. We only call this append event, and it will decide when the commit should happen, and it will generate a response and give back. That's how we were getting the response as well. So that's how this works. You can look at these other events if they are useful to you. You can maybe go through them, like however you like. Maybe for your use case, this can be something useful. And then there is a response.create event as well. Like I think this is used when you want the GPT model to generate a response now based on all the inputs that are sent. So you can see these are you can read about them. These are very interesting events, but we haven't used these yet. Like for us, only input audio buffer append was enough. And then we have server events. So server events is what we'll get back from the server. Client events is what we were sending to the Realtime API. So in the server events, you can see here what we have used. So in handle message, we have used these event types: respond.audio delta, response.audio done. So this is the place where we get this information from. There are session related events. There is error related events as well that we can catch. So right now we are not handling these, but we can read this. Session.created and updated events are also there. So these also can be read, and you can use this if you want, but we haven't used this. Conversation related events as well. Again, we haven't used these, but if you want, you can based on your use case, you can see what fits. There are input audio buffer, like committed, cleared, all these events are there. So when a speech started, when a speech stopped. So maybe you want to make it look something on UI, so you can use these events here. Yeah, this is what we are using from response, and we are using, again, let's go back, response.audio.delta. So if you come to response and .audio.delta, so this is where like the real-time API starts streaming their response audio back to us. So we'll get like chunks of audio, and this is the delta that we'll get. Delta means like just a chunk of audio, and done means like it's done streaming. It's our turn now. Ball is in our court basically. So this delta event is what we had used here. As soon as we get a chunk of audio, we put it in the receive audio so that it gets collected in the buffer and plays it accordingly. And then we have this function call as well. Of course, we are reading these event as well. So what we are doing is we are using this done event. As soon as we see a response.function called argument.done, that's when we know like this is the type of input that we'll get. This is basically the message that we get, and from message we are reading the name of the function and arguments, and then we are using those. For some reason, name is not given here. Arguments is given, but name was not given. But I just printed the message and I saw name was coming, so I just used name. Yeah, that's about it. Like you can print the messages and see for yourself as well. There's also this rate limit updated. If you want, you can read about it and use it accordingly. But this is how you make sense of this doc. Basically, these different events that you have. You can go through them and see if any of these events make sense to you for your use case and build some awesome projects using that. Hope you enjoyed this small tutorial. I'll see you in some next video. Thanks. Bye.